So let's continue our exploration of the pFsense environment. So we've set up pFsense, presumably, on our node. It has an address of 75.3. That raises the question, can we access 75.3 using 80.443 to access the web configuration? So let's say now we take a look at GUI setup, so complete the setup or completion of setup and exploration of the interface. So let's see how we get to this interface. So first, let's see whether or not we can nmap port 80 on 75.3 from one of the nodes on our WAN. That should tell us whether or not the port's available. So let's say from build 1, which is at 75.101, we try to scan 75.3. So there you can see it believes firmly that the node is inaccessible. ICMP is tried, and subsequently the port is scanned to see whether or not it's available. So nothing's available. So we should not be able to, from the browser, access 75.3 to complete the installation. Let's try that out anyway, but 192.168.75.3, and as you can see, it's trying, but coming back with no data, and this should ultimately fail. So we'll just stop it in its tracks. But how about accessing the internal IP address 1.1? So certainly this nmap works when querying the internal address from the other side. So let's paste that in, and it returns, of course, that port 80 is listening. So returns positively or affirmatively, and we can confirm that by querying, as we've already done, from the console of an internal node. So for example, Linux CBT ubuserv 1's console. Let's see if we can get some sort of action on this console here. And we'll navigate away as usual and back in, just to see what comes up there. Let's see if this gives us anything. Nothing so far. Back to ubuserv 1. And that's more like it. So nmap port 80 1.1 shows that it's open. And the same should apply for 443 as well as SSH. So those ports are accessible. So that presumes that from any internal node or any LAN-based node, we should be able to get to the web configurator to complete the installation. So how do we do that? Well, we have a GUI on this Ubuntu box that's on the F7 console, which should assist us. So say we clear the screen, drop the shell here for a moment, and then we navigate around to F7 console. And this will give us the appropriate interface. Let's authenticate. And we don't need the interface for long, so if you're constrained as we are within the dimensions of this screen, just bear with it momentarily as you access the web configurator and instruct it to allow access via its internal or external IPs on ports 80 or 443 for management. So if we can bring this in a bit, and let's see if we can grab this and just drag that over. So this gives us enough of a window to make some sort of decision. Let's just get Firefox going. Any browser will do, any supported browser. And let's try to hit 1.1. This will be the interface. So there's the interface for 1.1. And it's pFsense as the user, or as the password, that is. Admin as the user, pFsense is the password. And we'll tell it not to remember the password. And it presents us with the wizard to complete installation. So let's go ahead and click on next. So the host name, well, let's say this is going to be ucbt pFsense 1 with the typical domain of Linux cbt.internal. The fields were already pre-filled, and with DNS servers of 101 and optionally 102. If you separate them with a space, that should specify, or just specify on a separate command line depending on the interface. And this allows the DNS service to be overridden by DHCP, PPP on the WAN interface in the event that those protocols are configured, as is typically the case with consumer providers. So that isn't the case for us. We're using a static address, but in the event that the DHCP is configured, or PPP, which provides automatic addressing, then any of those helper addresses for DNS will override. But for now, we'll just go with our hardwired instances, but they'll override in the event that they're there. This is the default NTP server at pool.ntp.org, which provides pFsense time, and we'll go with UTC as our time zone, which we tend to for devices. The WAN interface is configured using static, but here are other supported protocols. For example, you could have pFsense PPTP directly into perhaps one of your headquarter or other central hub locations, or PPPoE or DHCP. Static works for us. And this allows us to spoof a MAC address in the event that a particular MAC is expected at the ISP provider's drop. And the MTU and MSS fields may also be manipulated as needed. Its IP is 75.3 and the upstream gateway will be 75.1. Again, these are items that we've specified during the console installation, but we'll just re-specify them here. And if you're using DHCP and a specific host name is to be specified, or if you're using PPPoE to connect to your provider, you can specify the details there. And ditto for PPTP, we're not using either of those protocols. Now the RFC 1918 blockage, which is the default, is what prevents traffic from our 192.168.75.0/24 network from communicating with our WAN as well as LAN space. So we'll tell it not to block it so that we can communicate accordingly. The bogon nets cover other nets that are not RFC 1918, but that should not appear on the internet. On your LAN, they're likely to, but on the internet, they should not. And notice it reads not RFC 1918. If you find that there are communications between protocols that use some of the bogon nets, you can just Google bogon nets to see if there are any traffic that may appear on your network that pFsense may block. Then you may want to disable blocking bogon networks in the event that pFsense is functioning as a firewall within your sphere. If it's an edge device, then these two can safely be enabled. And that's something we should always keep in mind. Now let's click on next. Let's move forward. The LAN IP, this is an opportunity here to change the subnet altogether. We'll go with the default. You can even constrain it to a certain number of bits. And we'll go ahead and move on. Admin password is the next opportunity to change this out. So let's say we do that right now. And this is used by both the WebGUI and SSH for connectivity. It's the same user. Then we'll reload to set the new settings associated with the server. Now, what does this mean? Does this mean we can now connect to the server from the LAN address, let's say 75.3? Well, it's reloading the firewall rules currently. And let's just give it a moment. It'll redirect us once the reload has completed, at which point we'll see the full menu and be able to interact with pFsense from the web configurator entirely. But that still begs the question, what about connecting to web configurator from 75.3? So let's just give this a moment. Because once we're connected from the WAN interface, then we no longer need an internal node or need to bounce traffic off of an internal node in order for matters to work. And the time on this local node is set to GMT as well. That's current. That's reflecting accordingly. So this claims it's still reloading. Let's see what's happening here. We could always, in a separate tab, try to see what's happening. Send some data to Mozilla, and we'll kill this. Congratulations, pFsense is finally configured, and so on. So to access pFsense's web configurator, we navigate to this space. Now, before we browse from this perspective, let's see whether or not we're able to communicate with port 80 from one of our other nodes, which would make it much easier from the Mac OS X box. So we can nmap from any internal node. Say we nmap v port 80, 192.168.75.3 from this node. RFC 1918 addresses are permitted now. Bogon nets are not. But there's still no rule to allow port 80 access, despite the fact that the console registers that you can access the web configurator on 75.3. So it isn't actually true that you can without a rule. You need a rule on the WAN interface in order for it to work. So that's something to keep in mind. So we need to define a rule. So, and by the way, if you want to access the internal interface of the router, that's 1.1, then you'll need to ensure that there's a route from your client into the 192.168.1.0 network through this particular router, which we'll set up momentarily on our Mac OS X instance and we'll confirm exists on our Linux instance. Otherwise, you should be able to just manage the system from the 75.3 external WAN interface. Now here we're at the dashboard. Before we go through all this, of course, it presents useful information, including the release of BSD. We know currently BSD is up to 10x, but 8.3 is what's used for pFsense. That's just fine. This is the latest build currently, 2.1.4, released not too long ago, within a month from when we're recording this. It gives you a firewall uptime, as commercial firewalls do. CPU type, DNS configuration, date and time, state table, how many connections, defaults 100,000 permitted. Only 46 states are currently in use, and you can show those states. The last time the configuration was changed. MBUF usage, load average, CPU usage, mem usage, swap usage, disk usage. It is a PC after all. Now in terms of rules, all rules are specified via the firewall interface, so we need to make sure we have that rule specified. So if we navigate to firewall rules, without knowing anything, we need to ensure that on the WAN interface, we allow traffic to port 80 and 443 through to any node. To add a rule, you can just simply click on the Add Rule option. You can also define a rule based on an existing rule. This is a rule that blocks bogon nets, and had we not removed the other one for RFC 1918, we would have seen other rules here as well. We won't get deep into rules just yet, but there are three classes: floating, WAN, and LAN. Floating can apply to any interface, any direction, so WAN, LAN, optional 1 through N in any direction, and it reduces the amount of rules that you have to write to filter traffic, to block or pass traffic. And any traffic that passes or should pass on the WAN interface should be specified on the WAN interface, of course. So we want port 80 and 443 to pass through. So we can create two rules, or we can begin with one and then subsequently add another. The default action is to pass, but options include block and reject. So you can also disable a rule. You specify the interface. You may have started on the WAN interface, but you can apply it to the LAN interface by alternating it, or any other optional interfaces that are available on the system. You can negate the destination or the source using the not. The destination can be any, but you must specify the port, and there's some shortcuts to ports here, or aliases to ports that are commonly referenced, such as SSH, HTTPS, so on and so forth. And you can log the packets that filter into this rule. And you can give it a little description, such as HTTP access, for example. Usually we separate out the rules, but you can specify a range of ports. But if you do, you'll include ports that you probably don't want. And again, since we're not looking at the filtering section, we'll just ignore these options below. These are advanced features. They're add-ons to rules. This will permit traffic coming in from any source. And if that's not your intention, specify a distinct source, such as the 192.168.75 subnet. But any source port 80 will be allowed through this firewall. But you can specify a network if necessary, such as 192.168.75.0/24, and that'll ensure that packets coming from 75.0/24 are allowed through on port 80, and that restricts other networks from getting through. Whenever you create a new rule, you must apply the changes, which essentially reloads the firewall rules, and it does so rather quickly, even if you've got thousands of rules. A brief look at the rule shows that it's to pass traffic, but you can toggle the status to pass or not pass. The protocol, TCP, the source port can be anything, the destination can be anywhere, but so long as the TCP port destination is port 80, then it's fine. It isn't queued in any particular way. It uses any gateway, and it isn't tied to any schedule, and it has a description. Let's apply the changes. That should allow port 80 access through the firewall. And let's take a look from the perspective of our Mac OS X box by trying to scan the server, see whether or not it comes back. And as you can see, port 80 access is now open, which means we should be able to connect to the pFsense web interface. So returns positively on the internal node, so that means C, or let's say we connect to node on LAN and complete setup. As part of completing the setup, we also enable rule to pass TCP port 80 from, say, 192.168.75.0/24 to any, and then test using nmap from WAN node access to, obviously, TCP 80. And that's affirmative. So that now means we should be able to, from the browser, hit 75.3 and have the interface come up. And once that comes up, we're set. So now we can administer pFsense, or at least explore the interface initially via 75.3. Now this is equivalent to enabling pFsense administration on your WAN interface if the pFsense device is an edge device that you may not want. And if so, then restrict port 80 access accordingly. So let's just note that this restricts TCP 80 administration to, obviously, 192.168.75.0/24. However, a rule with, say, asterisk as source permits all to administer, or at least connect to, pFsense from WAN address, which obviously may not be desirable. So just keep that in mind. Be sure to restrict it accordingly. And if it should only be administered from the internal net, then write the rule such that no access to port 80. Put an explicit deny so that port 80, port 443 may not be administered. Now, since we're here, let's add that additional rule for 443. So let's say f add TCP 443, obviously HTTPS rule for administration from 192.168.75.0/24. That way we can flip to secure administration for our studies. So then, to authenticate its admin, it's pFsense by default. It's clear text, so it can be parsed, so be careful of that. Let's check this out again. And actually, we've changed the password, so now it's something else. That looks good. So now we're in. So let's add this additional rule. Firewall rules. To duplicate a rule based on an existing rule, just add by specifying this plus symbol, add a new rule based on this rule, and then modify it accordingly. So the source is the same, only difference is the port. This time, instead of HTTP, it becomes HTTPS. The default range always starts and ends with the same port. That restricts access to a single port. However, if you specify a range of, say, port A to port B, then all intermediary ports are included as a result. And then again, that may not be desirable, because if a listener is enabled on one of those ports, then you potentially have problems. So now, after we apply the changes, both ports will pass, and a scan from the client should show favorably that port 43 or SSL is available. Let's just do 80,443 here. And this will come back momentarily as both ports being enabled. And then we can switch administration to SSL as needed. Now, what about the internal net, routing through the firewall to 192.168.1.1? In order to do so, you need a route. So let's do a netstat RN, for example. So we would need a route through 192.168.75.3, which isn't in this table, to get to 192.168.1.1, because currently any node residing on 192.168.75.0 is going to send its traffic to 75.1 if it doesn't match the current subnet. So it's important that your nodes that should communicate with this protected subnet have a route through the firewall. So let's say 5, ensure WAN nodes have route to 192.168.1.0/24 subnet, which is basically via the pFsense instance. Now, depending on the platform, will determine how you execute the route command. If you're on Linux, just do a route add with a net of, say, 192.168.1.0 and a net mask as specified here. One word, that is net mask of 22255s for our net, and a gateway of the IP address that's responsible for forwarding the traffic. This will add a route. It's not static. You can add the static entry to the appropriate interface configuration file for your distribution of Linux. For Ubuntu Debian, that tends to be etc network interfaces. So let's su in and make this change, or sudo either or. and we'll drop this rule in, followed by a netstat rn. That should show that in order to get to 192.168.1.0, we should go through 192.168.75.3. We could then try to nmap, say, 192.168.1.1, which is the LAN side of the pFsense router, to see if it'll pass traffic through. Notice nothing's coming back, although it should know the route to it. For example, let's try to send some packets to 192.168.1.102, which is our Linux CBT ubuserv 1 box there. So nothing's going through. Now, obviously, this is because of filtration. No traffic is allowed to go through the firewall currently because of the filtration rules, which we'll take a look at. Let's go back to the browser. So as it stands, bogon nets are not permitted. TCP/80 is permitted, and IPv4 TCP 443 permitted. So that begs the question, if we did a scan, which should have come back for 192.168.1.1, will it show up for those ports, or 102? And you'll see currently 80 and 443 for 102 come back. What about for 192.168.1.1? 80, 443, scanning those ports, trying to determine whether or not it's available. Nothing's coming back. So this is telling us the web configurator is not allowing the traffic back in on its internal port, but rather on its external port. However, the other node, ubuserv1, is responding accordingly. Now, how do we know this is true? Can we actually pass traffic to that node 102? Well, if we have a port for SSH, that should do well, or ICMP to ping, that should do well, either or. But the fact that 80 and 443 came back, insofar as mmap is concerned, tells us that it's available. For example, if we try to scan something that doesn't exist, let's say 103, it'll obviously come back empty. So we should trust our tool when it tells us that the port is open on those remote systems. And we'll confirm that momentarily as well. So we have our access into this interface now. Now we should explore it before we go on to rules. It's rather the default to delve into the rules. Now, the default page is a dashboard page. Let's close this out, which of course indicates that we have made a change to the firewall. So to get to the dashboard, status dashboard, and that takes us to this page. As we've mentioned, it gives you general information about the firewall. So let's just say 6 explore interface. So one of the key areas is, of course, status dashboard. And this gives us general information. This is basically the home screen, the default screen, although you can change the screen on a per user basis, and users are supported, of course. So this gives us general information about the server, about the router, and that can be useful in helping you to plan for expansion, etc. Let's take a look at this, and you see the specs that are here, all the interfaces on the right. This screen is manipulatable, so you can add widgets or screens that are of interest to it, for example. So anything you want to know, like services that are running on a system, and there are different services, of course, DHCP, DNS, NTP, APinger, etc. These all are default services, and they'll show you the statuses. Sometimes you have to restart services. If resolution, as we've mentioned, may be a problem, you may need to restart DNS mask. If the NTP sync is out of date, DHCP stops responding. But generally, these things run without much intervention. You can manipulate the interface, you can move things around, you can add the widgets, remove them. Look at this list for anything that's of interest and pop them in. So we've got interfaces, services status, perhaps a list of installed packages, gateways that are available in our network, and the list goes on and on. If something's moved in a place that's less than ideal, move it around. Just take it, drag it, and try to snap it into somewhere else on the screen. Usually if we pop it in over there, it drops into space, and you can alternate them accordingly by moving them around. That's your dashboard screen. Alter it as you see fit. The CPU usage, usually every time the page is loaded, will take about 10 seconds or so to update, giving you the latest information about the usage. This isn't real-time data. It's close to real-time. It's close enough to give you a sense as to how your system's performing. Nothing to be alarmed of here, 13% of a gig. That's just for basic operation of the firewall operating system. Now, we didn't save our layout, so we lost it. So for example, let's say we pull back in maybe install packages, and that's going to pop it over here. There are currently no packages installed. Let's say we drop it, bring this up to here, and we'll look at that later on, of course. Let's try to snap that in. So to save the change, you click on Save Changes, but let's pull back in something else that might be of interest, maybe the gateways to which we have connections. Let's see where that popped it. And this shows us the default gateways that are available. Let's see if we pop that in. And then any changes that are to be committed, just click on Save Changes and that'll commit it accordingly. Let's see if we can get that in there. Otherwise, when you refresh subsequently, you lose all changes. So click on Save Settings. And these settings are applied now to this particular user, such that when you refresh, you'll have the new screen, obviously. So status, dashboard. Status gives us all sorts of information. Now, if you start simply from left to right, you've got the system screen, and it's got a whole bunch of options, including the advanced menu, which brings up tons and tons of options. For example, if you wanted to make the administration interface more secure, flip it to HTTPS. And this uses the default certificate that's provisioned with Web Configurator, and that's fine. You can always generate new certificates, include them in the system. There's a whole certificate management area where you can take care of that. You can flip the port that it listens on. Doesn't have to be 443. Max processes, this limits the number of simultaneous connections, for example, to 2. You can redirect connections and display messages when users log in. You can define alternate host names and fight against beast SSL attacks or disable HTTP refer enforcement checks and so on, so that you can restrict how users get to your site. You can configure serial communications. So for example, have it listen to a COM port, for which we have none. This is all a virtual environment, of course. You can also password protect the console menu. Clicking on this, it restricts it to the user's credentials, and that applies the next time the firewall is rebooted. So those are the two tasks. So let's say system advance, let's say B1, force SSL for administration, and B2, force password at console prompt. But this requires a reboot, as was mentioned. That's definitely the case, as we saw. Let's pop back here. So let's proceed anyway, and then connections going forward will be SSL. So if you try to access any link with HTTP going forward, the interface Web Configurator will force you to use an SSL session. Now, in System Advanced, every component that you see listed here has specific settings that govern how that particular component runs. Firewalling, NATing, IPv6, how the interfaces are to operate. Extra features, advanced features are specified here. We'll just gloss over them quickly, and as we need to, we'll pop back in and take a look at them. These system tunables are tantamount to any of the system metrics that can be defined from the command line of BSD that impacts in particular network configuration. These are the ones that can be tuned, which will allow more or less packets and so on and so forth. Notifications area will use two protocols. Growl SMTP has the option to use system sounds to generate audible alerts in the event that there's an issue. There's a certificate manager. In this area, you can see the certificates that are listed. There's a default self-sign Web Configurator, which works for most cases, but for prod, you'll want to generate your own certificate and specify it accordingly. You can also specify your internal CAs so that clients can consult them and not have to deal with any error messages regarding the SSL certificates. You can update the firmware. So if there's a new firmware for pFsense available from the website, you can update it through the GUI interface, of course, backup before doing so. General setup is what we specify in the subsequent portion of the installation. So which DNS server, the host name, the domain name, the time zone, NTP settings, and so on. That's under general setup. High availability, whether or not you'd like to log out, any packages that you'd like to install. Currently none are installed, but a whole host of packages are available. We'll take a look at a couple later on in a separate section. Setup wizard, routing. Routing allows you to configure the routed interface, also to define multiple routers for redundancy. The setup wizard reinitiates everything, so that will ignore, asking us to respecify the settings for the interfaces and so on. And of course, a user manager gives you an area with which you can define additional users at regular user level, whereby you'd have to specify access to specific screens, or at the admin level who has access to everything. So systems administrator description. You can tell when users time out. 0 never times out sessions. The default is 4 hours, 2 hours, 240 minutes. You can reduce that if necessary. Maybe 20 minutes is a default, which is usually fair to ensure that things are working well. You can define additional servers for authentication. Default is a local database, but you can add, let's say, a remote system based on the common protocols LDAP and Radius to fetch those users who may access the system. So this can plug directly into typical central authentication databases such as Radius and LDAP. And of course, you got the interfaces menu, which defines LAN and WAN by default, and for n number of optional interfaces that you've got. Click on any interface to see how it's defined for the different protocols, IPS v4 and 6, spoofed MAC addresses, MTU, MSS, if it's static or DHCP, the subnet, the upstream gateway to which it's connected. For IPv4, well, this interface isn't. The 192.168.75 or WAN interface is an upstream gateway, but the internal does not. Whether or not IPv6 should be tracked, whether or not you should block private networks or boga networks. We have many changes here. Whether or not you'd like to have the interface enabled or disabled. The WAN interface will have an upstream gateway, of course, and that should be in here as gateway WAN 192.168.75.1. It blocks boga networks, non-RFC 1918 networks, and it's just regular old Ethernet, so there's no need to alter the MTU. It isn't connected, say, to a PPPoE interface that needs to be adjusted. The firewall menu takes care of, as we've mentioned, firewalling, NAT, the rules, schedules, shaping traffic, virtual IP addresses. Any services that the firewall or pFsense may serve will be configured through the services menu, such as DHCP, DDNS, forwarding of DNS information, let's say, and it's enabled by default, as you saw. Let's say where to send DNS requests, and the default is to send it to its local configuration, as well as DNS servers that have been hardwired or pulled in from DHCP, just as a normal off-the-shelf router would, and other types of services, IGMP proxy, load balancing, where to synchronize time, whether or not it's connected to a tier 1 time provider such as a GPS provider, Wake on LAN, SNMP common protocols, whether or not it in and of itself should be a PPPoE server, and it can do so using its local database or LDAP, such that your users on the internet can PPPoE into the server. VPN, the common protocols we've mentioned, PPTP deprecated, L2TP still in use, IPsec, OpenVPN for SSL, and the status of all the different metrics on your system, which we'll spend a separate section looking at. Of course, status dashboard is the home page, but you've got status information for everything that the system tracks to get a sense for what's happening. Perhaps most useful would be the logs area, the system logs area, which tells you almost in real time what the system's doing. And then a helpful diagnostics menu, which allows us, again, through its aggregated nature, to run utilities like TCP dump or traceroute to find the routes between clients and servers and so on, or to trace packets or to see the top packets running through the system as we saw from the console. And this is just the same dump represented through the WebGUI and so on. So as traffic ramps up, you can have a real-time look at the offenders. Sometimes the offenders may be infected systems, malware systems, so on and so forth. You'll want to look at pftop just to get a sense for what's flowing through. You typically follow the bytes and see if there's a pattern between the source and destination addresses, or even a particular source address that's targeting various destinations using more or less similar ports. So you'll track this to get a sense of malicious or just common activity on the wire. And this is 7577 as the configuration. And this, of course, should be an old configuration. It's now 75.3. So something's 7577, something sent packet to 75 from 7577 to 75.1, and that's something we could ping. So from Diagnostics, you can try to send some packets over to that node to see if it even responds. Let's see what we've got here: 192.168.75.77, IPv4. Use a default source address. Let's see what it comes back with. Let's see if there's any listener indicated. There shouldn't be, but let's see what it comes up with. It's doing the ping behind the scenes. It'll return the standard out momentarily through the web interface. Again, PHP is just a front end. So it sent it. It lost all the packets. So that entry is something that should be investigate it. It could just be stale information out on the wire concerning that particular traffic from 7577 off to 7571. But pftop should give you that information. And also pftop is going to show information that's old. So if at one point it was 7577 but no longer, then it just becomes old information. Or maybe there's a new node that's using 7577, although the ping didn't seem to reflect as much. When you do send some packets using ping, you can see that you can specify the source address that it should use. So if it should use the WAN, or if it should just default interface, either or. If you don't believe the results, then force the interface that it should use and see whether or not it comes back with any meaningful results. Let's see what this is doing. It's trying to send some packets. Again, it's all behind the scenes, so unless you do a TCP dump, you don't know what it's actually doing. It's still lost packets. Now this again, pinging from the perspective of the router should allow ICMP echo responses to come back in, so you can trust that 7577 is currently not accessible on the wire. You can always try to ping from, say, a shell just to be sure that it's not just the firewall filtering, because firewalls are notorious for that. So 192.168.75.77, and this shows us nothing's coming back. So that should just be old results for that particular node, whereas 75.3 is the router, but it's not, or the firewall, pFsense, which is a router, but it's not permitting ICMP packets through the router. So we'll look at that in the appropriate section. From this interface, if you need to perform resolution, let's say of something out on the net, like cbt.com, this should go out, fetch data, and come back with some sort of resolution, as you would with dig or host or any tool from the command line. Again, it's just front end to those underlying command line tools that are provided by BSD Unix. So this should come back. There's the IP address, the query time that it took off of the local system with the server that it used, and so on. You can get information, additional information, who is, IP info about the IP address to learn who owns it, so on and so forth. Using a little command prompt, if you wanted to run a command on the server, it tells you do it at your own risk. We're typically discouraged from doing anything from the CLI on pFsense systems because it's a self-contained, self-enclosed distribution. So we should use the interface wherever possible so we don't run the risk of clobbering things. ARP table, this will show the relationships between systems that your firewall knows about and their MAC addresses, so IP and MAC addresses. So it knows build 1 because we've been communicating. That's its MAC. It's on the WAN interface. It knows the router, 75.1. It knows ubuserv 1 on its LAN. It knows pFsense 1, which is itself on the LAN. And it knows two other MAC addresses, 75.3, which is itself on the WAN, and 75.92, which is another node that's on the WAN as well. And the WAN for us is really our internal network. You can edit config files, but again, discouraged from doing so. Factory defaults. This will, of course, wipe out all the settings, resetting the LAN to 192.168.1.1, which is fine for us, but resetting everything else, so this would kick everything off, so that's something we definitely don't want to do. You can halt the system, NDP, and that shows us v6 data, pfinfo. This will give us detailed packet information. Momentarily it gathers it from the OS as we normally would, and it shows you for the different protocols, rates of traffic passing through for different interface types, so you can get a sense for which interfaces are busy on the various protocols. Not by IP by default, but just to get an overall sense as to how much traffic's passing through your interfaces. You can reboot, check your routes, smart status for smart supported devices, such as SATA drives and other types. The sockets that are associated with your system. So the more connections, the more sockets, but default sockets will be the listeners that are configured. And you'll expect to find protocols such as IP and UDP and TCP for NTP and other instances. So LIG, DHCP, DNS mask, NTPD, these are all TCP UDP services. The PHP instance itself, it also binds to IPv6, so you can administer it there as well. And there's state information at the bottom telling you what the different states mean. For UDP, you'll get no state data, so don't expect any there. That's for obvious reasons. Those are under sockets. You can show all socket connections. These are listeners by default, just like doing a netstat AMP TCP or UDP or otherwise. But if you show all, it'll show all connections, including established connections and connections in other states such as finish, time, wait, and so on. So this table grows considerably as more users are using the firewall for obvious reasons. The socket table, that is. And in the state table, you see the actual states of the connections flowing through. So 102, which is our ubuserv box, has a connection out to 75.3, ultimately out to 74.125. This could be an update that's running against maybe security.debian.org. But it's currently established, so it's running behind the scenes unbeknownst to us. And then we see some other traffic, 75.102, 75.3, ultimately going to this address 74, which is again somewhere on the Debian network, and some other states of other packets flowing through the node. Again, this is all subject to change, so we won't focus in on it, but you can filter looking for specific nodes, let's say 192.168.75.102 to see what states are there for that particular node. Then you have summaries of those states, so this sums up the data. So 102 node has 4 TCP7 UDP states going, and the source ports are as follows. Destination ports 1, so it's probably the same application, and you can also see it by destination IP to see which nodes are being contacted most frequently. So this node is the most frequently contacted node, seemingly, at least for now, but again, it's subject to change, as well as by destination IP. But again, on the return traffic, destination IP becomes your local internal node, so that's why you have the pairing below to show the nodes that are doing the most communication. So 7577 was talking to the router, 102 is talking to this guy out on the net frequently, and occasionally 198, 100, so on and so forth, 198.60. Again, it's all subject to change, so we won't focus in on it with any sort of information. System activity. This tells you what the processes is equivalent of PSAUX, PSEF to show you what the system's doing. Most processes on NIC systems tend to be sleeping, and the system's using roughly 18 megs fully, with the rest not doing much currently. System activity, different tables are available. SSH lockout, snort, bogon networks, and these tables are extensible. So these are bogon networks 169.254. That's usually used for flat subnet communication when DHCP fails, and some other addresses. These are all considered bogon networks that should not appear on the WAN interface or on the internet connection. Snort, virus, web configuration, they're all empty, and you can also create additional tables and extend the tables accordingly. But again, not focusing on that just now. You can even test the port just to see whether or not the system responds. So let's say whether or not linuxcbt.com responds on port 80 is the equivalent of doing a telnet. Sometimes we do this just to see whether or not it comes back. Is it available? Connection successful. That tells us it's listening. So that's a nice, useful feature to have built into the firewall as well. And you've got a help screen, of course. It takes you largely over to pFsense, so you can get some more information about it. Now, what we're going to do at this stage is reboot, because we're going to make sure that the system forces password authentication at any of its consoles, serial, SSH, etc., and it will continue administration from there. So let's reboot it. We'll know it's rebooted because we'll be unable to pass traffic from our local net to the subnet and vice versa. So for example, previously functioning nmap, let's say, of 1.102, once the system reboots will fail. It's currently discovered as open, but subsequently will bomb out. And there we see it seems to be bombing out here as a firewall reboots. And from the console, we should be able to see when it comes back up, or just send some pings to the distant node. Although ICMP is currently disabled, so when the nmap comes back, that'll be the equivalent. So let's see what this is saying here. Now, we no longer need this graphic. In fact, we can drop from it altogether using a Control-Alt-F1. And that'll just pop us back there, saving some resources, and then go back to getting started, and then CBT pFsense 1. Its console should reflect when it comes back up, and when it does, we should be able to drop this GUI for the time being, as it will no longer be necessary. We will only revert to it when absolutely necessary. So starting its logs, bring up interfaces. It even loads the VLAN service, although there are no VLANs currently defined, but typical 8021Q is supported by default. Now notice it needs a login. So you do not see the interface without logging in. So if you try to log in as admin, you'll need the appropriate password, and then you see the menu. Then you can log out. It says SSH only, but it impacts the console as well when there's a password defined. So just make sure you keep that in mind. You'll have to be able to present the appropriate credentials. So we're done with this node. Let's pop back over. Let's just say that we 7 reboot and ensure password necessary. Well, let's just say ensure the following. So A, password required to administer pFsense from console, and SSH, which means we'll test it from the shell, and confirm web configurator access. So let's just wrap up by doing those two. Let's pop back over to here, refresh. Let's go back to 75.3, get away from the reboot screen. And there it allows us in. We'll pop in. We're going to let time elapse to make sure that it kicks us out. Never for this. And then back to our shell. It should be here. We should then be able to nmap 102, and it comes back accordingly. And what if we tried to SSH, let's say, as admin to 75.3? We don't have SSH listening there. It's still on the internal interface, so we'd have to get to the remote system and then come back. So that would mean, let's say, popping back over to this node into VMware vSphere client temporarily. This should be our last go at it for now. And then back to the console of ubuserv 1. And then we'll have to have a firewall rule that permits SSH access through. We're just keeping the firewall rules to a minimum without jumping the gun, just to be sure that we have the firewall running as we expect it to. So let's bring this down back to ubuserv 1. And then let's just go back to the console quickly. And let's try to log in. Then let's try to SSH back to the router itself. Although you don't have to specify the user, it'll default to admin. Or alias is the user root for admin. And if this doesn't come up, let's do an nmap 192.168.1.1 443.80 50 443 5380. So SSH is currently not open. So when we do open SSH, then we'll confirm that the console requires a password. So we'll do that in a subsequent session. So let's kill this, save some resources, and we should be fine. Just lock the screen here. And then we'll pop back over to our Mac OS X, and that should be good. So we're looking good at this stage. We'll clear this. This will eventually time out. It's up and running. It's passing traffic. And we'll continue studying pFSense's wonderful interface momentarily.